All right, so first thing we're going to do today is Unit 8B.5. And what we're going to be doing is, this is called Analyze Statements About Logs. Analyze statements about logs. Okay? Most of what we're going to be doing today is just converting between two forms. Okay, so it's stuff that we've definitely done before. For the first couple, I'm going to ask you to write an equivalent equation. Write an equivalent statement. Write an equivalent statement to 27 to the 1/3 equals 3. Write an equivalent statement to 27 to the 1/3 power equals 3. So all I'm really asking you to do is go in between exponential and log form. So what form is this in? Is this in exponential or log form? This is exponential form. So I want you to change it to log form. So we're just going to do this backwards. So 1/3 is the exponent on, so you write equals log, is the exponent on 27, that makes 3. That's it. Okay, first couple should be very simple on your homework for this. You're only going to have 11 questions.
Can you write it like reversed?
If you wrote log base 27 of 3 equals 1/3, that is fine. Doesn't it matter which side each one is on. Okay, so if it was flipped, that's fine. As long as they're, the 27 is still the base, and they're in the right place. Okay, again, try another one. For number 2, again, I want you to write an equivalent statement to x to the z equals y. X to the z equals y. Write an equivalent statement to that. So again, just rewrite this in log form. X to the z equals y. How would I write that in log form?
Z equals log xy.
Exactly. Z equals log base x of y. That's it. Z equals log base x of y. Okay, should be fairly simple. Okay, let's try another one. For number 3, I'm going to know when is the following statement true? Okay, when is the following statement true? That 2 to the log base 2 of x equals x. Okay, when is this true? Your choices are A, for all values of x, B, for some values of x, C is for no values of x, and the D choice is can't determine. So when is it true that 2 to the exponent of log base 2 of x is equal to x? Is that always true? Is it sometimes true? Or is it never true? Okay, we're going to raise our hands and let's see. Okay, who thinks it's A? For all values of x, this is true, and you have to vote. So who thinks this is A? For all values of x? Okay, a couple of you. How about B? Who thinks this is true for some values of x? Couple. Okay, how many think it's for no values of x? Okay, how about D, can't determine? Okay, let's try this again, because like I said, everybody has to vote. So you have to think. So you can't just, you have to think. So you have to vote. Okay, let's try again. How about who thinks it's A for all values of x? Okay, how about B? How about C? No values of x? Okay, how about D? want you to look back at your, let me see which notes are they. Look back at your, I gotta look at which one notes it is, I'm figuring it out. 8B.3 notes. Look back at your 8B.3 notes. Look back at them and then let's think about this again. Or you could look at, look, this rule, that's a regular seagull, or that's an upside down seagull. This is an upside down seagull. So what does it say? For some values of x. Because x cannot be 0, 1, or negative. So look, I have that up on the board for you on purpose. Okay? Listen, I promise you that there will be some of these problems on your test. Okay? I promise that some of these problems will be on your test. So you have to know the exact rules. Okay? This only works for some values of x because it will not simplify if you have a negative, a 0, or a 1. Okay? So you have to know the exact rules for these types of problems. Okay, let's try another one. For number 4, again, I just want you to write an equivalent expression. Write an equivalent statement. Write an equivalent statement to log base 2 of 32 to the x power. Log base 2 of 32 to the x power. Just out of 10. We'll check if it's right. Yeah. No. So if I want you to write an equivalent statement, okay, we're going to first start by rewriting this. Okay, this is not a problem where you want to put x equals because there's already an x to begin with. So how can I make 32 into a base of 2? 2 to what power equals 32? 2 to the 5th. So 2 to the 5 times x is 5x. Now you can use the rule, make it a seagull problem. 5x is your answer. That's it. Okay, so an equivalent statement to that is just 5x. Okay, 32 is written as 2 to the 5th, right? 32 is equivalent as to 2 to the 5th. Okay, 2 more and then we'll be done. Okay, for number 5, again, for number 5, I want you to, again, write an equivalent statement. Write an equivalent statement to log 100 to the x power. Write an equivalent statement to log of 100 to the x power. First off, what's missing here?
The base.
The base 10. Okay, can I rewrite this as a base 10? Log base 10 of 10 to what power equals 100? 10 to the 2nd and multiplied by x. If you do your seagull problem here, our answer is just 2x. Okay, our answer is just 2x. Questions on how I did that? Okay, last one for number 6 here. Last one for this set of notes. I want to know if the equation y equals 1/2 to the x power is graphed. If the equation y equals 1/2 to the x is graphed, I want to know which of the following values of x would produce a point closest to the x-axis. if the equation y equals 1/2 to the x is graphed, which of the following values of x would produce a point closest to the x-axis? And our choices are 0, 1, 2, and 5/4. So which of the following would have produced a point closest to the x-axis? I'm sorry, 0, -1. My bad. -1, 2, and 5/4. Any ideas how I'm going to do that? What do I have to do? Do we know how that graph would look if I graphed it? Yeah, kind of. Do we know what exponential function graph? Is this an exponential graph or is it a log graph? This is an exponential function graph. Okay? We've done these before. If you did not recognize this as an exponential function graph, you could make an XY table. Okay? What numbers would I be plugging in? Would I plug in for X or for Y? What letter, I'm sorry, would I plug in for? For X, because whatever's in the exponent. So X, you'd pick 2, 1, 0, -1, and -2. And then you just plug them into the equation. So if you got y equals 1/2 squared, that'd be a 1/4. 1/2 to the first power is 1/2. 1/2 to the 0 power is 1. 1/2 to the -1 is 2. 1/2 to the -2 is 4. So if you did not automatically recognize this as an exponential function graph, one that you should already know what it looks like, you could graph this. Okay, so over 2 up 1/4, over 1 up 1/2, over 0 up 1, left 1 up 2, left 2 up 4. So this graph is getting really close to, but not quite touching, the x-axis. So which point of x, which value of x produces a point closest to the x-axis? Is it the most positive or the most negative? Most positive. Which one's bigger, 2 or 5/4? 2. 2 is the biggest. So it is the most positive, so it produces a point closest to the x-axis. Okay, does anyone have questions on how I did any of that? Okay, homework for this objective is going to be, worksheet 5. You are doing numbers 1 through 11. Worksheet 5, numbers 1 through 11.